Moving the CG. There's a standard formula that can be used, which is MD times MdCG. Little m is the mass to move, multiplied by little d, the distance that the package is moved, equals large M, the mass of the aircraft, multiplied by delta G, which means change, the distance the CG moves. Calculating the mass to move the CG. The distance between cargo hold A and B is 5 meters, with an aircraft basic empty mass of 2,000 kilograms. To move the CG by 15 centimeters, how much mass is required to be moved? Using M times D equals MdCG, the mass to move is M multiplied by 5 equals 2,000 multiplied by 0.15. Therefore, M times 5 equals 300. 300 divided by 5 means 60 kilograms needs to be moved. Calculating how far the CG moves. The distance between cargo hold A and B is 6 meters. With an aircraft basic empty mass of 3,000 kilograms, a package weighing 30 kilograms is moved from cargo hold A to B. What effect will this have on the CG? M times D equals MdCG. 30 kilograms multiplied by 6 equals 3,000 multiplied by delta CG. 180 equals 3,000 multiplied by delta CG. So delta CG equals 180 divided by 3,000, which is 0.06 meters. The centre of gravity moves aft by 6 centimeters. Moving mass questions. The loaded mass of an aircraft is 12,400 kilograms. The aft CG limit is 102 inches aft of the datum. If the CG as loaded is 104.5 inches aft of the datum, how many rows forward must 2 passengers move from the rear seat row, 224 inches aft, to bring the CG onto the aft limit if the seat pitch is 33 inches? Assume a passenger mass of 75 kilograms. The answer is 7. Exactly 6.26 rows, or 206 inches. The effect on CG position of adding or removing mass. The initial total moment method. Calculate the initial total moment from moment equals aircraft mass times CG. Calculate the load moment from load moment equals load mass multiplied by arm. Decide whether to add or subtract the load moment to the initial total moment using the following rules. Plus if the mass is added, minus if the mass is subtracted. Plus if the mass is aft of datum, minus if the mass is forward of datum. To see the overall effect, a plus and a plus makes a plus, a minus and a minus makes a plus, a plus and a minus makes a minus, and a minus and a plus makes a minus. An aircraft weighs 3,000 pounds and the CG is 70 inches aft of datum. The aft CG limit is at 71 inches aft of datum. What is the maximum weight that can be loaded into a hold at 110 inches aft of the datum to bring the CG to the aft limit? New total moment equals old total moment plus or minus the additional moment. The new total moment will be the aircraft mass plus or minus the additional mass multiplied by the new CG position. Old total moment is aircraft mass multiplied by the old CG position. The additional moment is the additional mass multiplied by the baggage hold arm. So new total moment equals old total moment plus or minus the additional moment. That will be 3,000 plus A multiplied by 71. 3,000 times 70 plus A times 110. This becomes 213,000 plus 71A equals 210,000 plus 110A. Rearranging 213,000 minus 210,000 equals 110A minus 71A, which becomes 3,000 equaling 39A. A is therefore 3,000 divided by 39, which is 76.9 pounds. An aeroplane mass is 1,950 kilograms. If 450 kilograms is added to a cargo hold 1.75 meters from the loaded centre of gravity, the loaded C of G will move. Using the formulae, new total moment equals old total moment plus and minus the additional moment. 1,950 plus 450 multiplied by A equals 1,950 multiplied by 0 plus 450 multiplied by 1.75. This becomes 2,400 multiplied by A equals 787.5, which becomes 787.5 divided by 2,400. A is therefore 0.33 meters. M times D equals MdCg may also be used to solve this question. Little m is 450, D is 1.75, the aircraft mass is 2,400, and delta Cg is unknown. Multiplying 450 by 1.75 gives 787.5 equals 2,400 multiplied by delta Cg. Rearranging 787.5 divided by 2,400 is 0.33 meters. The centre of gravity moves aft by 0.33 meters.